This is the screencast for section 5.2, example 4. Could it be? What is this? She's teaching us how to do it on our calculator first instead of making us do it the long way? Yeah, it's true. I'm actually going to teach you how to find the exact area for anything on your calculator first. That way it gives you the opportunity to check your work. Now, of course, remember the AP exam has non-calculator portions, so you will definitely still have to do this without your calculator, but this way you get to know that you have the right answer every time. And there's 2 different ways that I'm going to teach you how to do it. Alright, so first of all, example 4, using NINT. Your book calls it NINT. NINT is N integral. Your calculators don't use it that way anymore. 83s do, 84s do not. So whenever the book says NINT, just know that that means the integral using your calculator. Alright, so A asks for the antiderivative or integral from -1 to 2 of x sine of x dx. Now, I don't know what shape that is. I only know that it's asking for -1 to 2. So I'm looking for that area right there from -1 on the x-axis to 2. So this is all a positive area, and I'm going to use my calculator. So what I will do is go to math number 9. There it is, FNINT. See that? NINT kind of. So number 9, and then you just put the numbers in where they're supposed to go. So -1 is your lower bound of integration. Upper bound is 2. Your integrand is x sine of x, making sure you're in radian mode. Yep. And then, last but not least, your variable of integration is x. And I get 2.04-ish. So I put on here how to do that with your 84 or your 83 if you needed to. I just used y1 and had the equation in y1 because I was graphing it in the first place, but you could just enter x sine of x if you want to, like I just did. Alright, part B, I want to know the antiderivative or the signed area, so positive or negative depending on whether it's below or above the x-axis, from 0 to 1 of 4 over 1 plus x squared dx. So now that means I am looking for this area right here from 0 to 1. And I put that in my calculator as shown, and I have 3.1415. Oh, does that sound familiar? Yeah, that's pi. Interesting. Pi. Does this look familiar? Should remind you of something. Anyway, part C, the antiderivative from 0 to 5 of e to the negative x squared. So we're looking from 0 to 5, and 5 is it's going to get really, really, really thin out here, but it's still looking from 0 to 5 of e to the negative x squared dx, and that I get as 0.8862. Well, you get the idea. So now try problem number 33. We're going to do a different way with our calculator. You already have this option over here with Math 9 on your main screen, but you can also use your graph to calculate the area. So what I did is I just picked a good window, here's my window, and graphed the function. I don't know why y4, but that just was where it landed, so fine. I showed you how to do it in Math 9 here, but I want to show you how this other method also produces the same exact answer. So on your calculator you have your graph, and on your graph you can do second calc, and then look at that, number 7 is the integral f of x dx. Now look at number 6, dy dx. Uh-oh, look at that. What was that for? But number 7 is the integral, so hit number 7. Now it asks you for the lower limit. Now you can choose to scroll over, or you can enter an exact number. And here we definitely know exact numbers. They're 0 and 5. So my lower limit of integration is 0. Enter. My upper limit of integration is 5. Enter. And then it fills all of the area that I'm looking at and gives me the integral, the answer. I still get 0.9905. Now to get rid of that black area in there, you have to do second draw, and you want to clear draw, clear whatever was drawn on your graph, and it'll regraph it for you, but without that area filled in.